two approaches. One is inductive approach, the other one is deductive approach. Both of these approaches try to access the research question with methods that are that may look like radically different, and that create a confusion in the among the young researchers that they are antagonistic. My effort here in 60 minutes would be to enable not antagonistic, in fact they are complementary, and they is something like namaste. We use both the hands and they are complementary in greeting a person. In greeting a research question, both of these approaches would be needed, and it would be excellent if the biomedical scientists start learning inductive approaches and social scientists also get familiarized into deductive approaches. Unfortunately, what has happened because of the glamour of science or glamour of exact science, most of the social scientists have also trying to join the bandwagon of the exact science. And in their hurry to say that they are not sociology, they are social science, they are not politics or political studies, they are political science, they are confusing science with deductive approaches. And most of us, till our 10+2 educational training, pedagogical training, have been so much mesmerized by mathematics or statistics that we think that unless we are able to measure certain things, those things cannot be called a reality. So means the strength of humanities has been lost in the later part of 20th century, and that's a paradox, because early 20th century saw the rise of a second wave of research methods, and that although we have been practicing inductive methods of exploring research questions since ages, thousands of years, but in 20th century of formal institutionalization of inductive research, the practitioners of the inductive research were so mesmerized, so glamour struck by the deductive methods and statistics that they lost their way. And probably we also lost our way in losing the phenomenal beauty of inductive research in biomedical sciences. There are two types of logical pathways, and for the beginners in research, let's start from, say, two domains, specific and generic, say contextual and something like a ready-made garment, a tailored shirt and a ready-made shirt bought from the market. So tailored shirt is contextualized. It has been customized for my usage. And the one shirt fits all, or something like small, medium, XL, double XL, those types of categorization and marketing them for entire humanity in the business of garments, same thing is happening in research. We are, say, in deductive research, we call them as fixed effect models and random effect models. So if we have to take medicine, we have to take medicine, say, telmisartan 20 milligram or 40 milligram or 80 milligram. We don't have the liberty of consuming telmisartan 82 milligram or 46.5 milligram, because market is so woven around deductive or say generic approaches that we have reduced this liberty of personalization or the art of medicine for prescribing a therapeutic intervention or preventive intervention. Similarly, those things may be happening in humanities as well. And humanities may also be quickly losing the contextualization, and with contextualization or a specific um, address to a particular approach to a particular research question, we may be losing the beauty of inductive logic. The inductive logic is heavily based on specificity, and it starts from specific and evolves towards generic. On the other hand, deductive logic, which is virtually the ruling logic of the world today, it starts from generic, then theorize, then hypothesizes, it makes, and then collects the data to test and confirm those hypotheses. That means ultimately we try to generalize and we try to force those generalizations on the complex reality that's called the universe. And there we probably fail to be inclusive about the art of medicine or art of scientific research, biomedical research, or anthropological research. And we ultimately fall in the trap of mathematization of entire biomedical research. On the other hand, the first logic, inductive logic, starts from specific to generic. It starts from observation, it infers, then it hypothesizes, and it generalizes. Later we'll come to this particular slide in a different graphical way and would realize that where induction ends, deduction begins. So they ultimately, it's a circular cycle to address a research question. Some of us may be uncomfortable that we are here to understand qualitative research, methods of quantitative research, but where would that inductive or deductive approaches fit in? So if we are so comfortable with method type of terrain, then if we fit those approaches, qualitative research generally follows inductive approach, and the quantitative research generally follows deductive approach. We can say, but they are not mutually exclusive. We can say that if we mathematize our methods to address a research question, we are generally following deductive approach. And if we try to generate, we are generally following inductive approach, and we are following the path of qualitative research methods. But if we realize most of the critical decisions made in our life have both these types of approaches, ultimately I'll talk about in the last three slides, I'll talk about the abductive approach that virtually assimilates both inductive as well as deductive approaches. So for the beginning, we research methods to have both types. We'll have both types of armamentarium. We need infantry, we need air attack as well. And for for the beginners, epistemology means Jnana Shastra. The way we approach the domain of knowledge is epistemology. And there have been theoretical debates all through last 2 centuries about these two approaches. And just to familiarize you with some glossary here, that some of the keywords that we use here are, um, one of them is nomothetic approach. A nomothetic approach is a tendency to generalize, but tendency starts from somewhere, and that tendency starts, if we have a tendency to generalize, we will start from a specific contextual situation. So I'm betraying a sentiment that nomothetic approach would sit somewhere in the domain of qualitative research methods or inductive approach. Inductive approach, qualitative research methods, or nomothetic tendency. Then, no, sorry, mm, uh, tendency to generalize, nomothetic approach tends towards generalization, tendency to generalize. So it starts from specific, and there's an overlap. So there are two major words thrown in the arena here, nomothetic and ideographic. So we were grappling with inductive, deductive, qualitative, quantitative. Now we have two other heavier words, ideographic and nomothetic. Ideographic tilts towards qualitative research methods or inductive approaches, and the nomothetic tilts towards deductive approaches or quantitative research methods or mathematization. In ideographic, we specify things. We start from specificity. That's why we use inductive approach and qualitative research methods. In nomothetic, we have a tendency to generalize like ready-made garments. And the most extremist approach would be positivism here. So now other two conceptual words are emerging. Positivism, the other extremity is reflexivity. So there are two bubbles, extreme bubble on left hand side and extreme bubble on right hand side. Positivism and reflexivity. Sometimes they look like positivism versus reflexivity. So what is positivism? Positivism means if anything, if we are unable to measure anything or we are unable to reduce the reality into variables and unable to measure the variable, it is not reality. So anything that cannot be measured is not real. That is physical exact science. And it looks very cursed and very stubborn. But fortunately, they were much more plastic in 20th century. They approached towards humanities, towards methods of social sciences, towards methods of ethnography and social anthropology, and they were moving from positivism to post-positivism. So there was a one step forward to shake hands with social sciences methods. On the other hand, social sciences methods also moving towards deductive approaches to shake hands, but they were a bit hesitant. So anti-positivism emerged somewhere around mid 20th century. And if we see the history of two distinct research methods across 20th century, we will see much more plastic approach from deductive scientists rather than inductive scientists. And two very disturbing things are happening at the same time. A desire to shake hand and an amount of suspicion. Deductive scientists are very suspicious about reflexivity. And social scientists are very suspicious about linear models like ANOVA or statistical comparisons. Both of them have very strong merits in their arguments. But when it comes to finding a middle path somewhere in between, what we are seeing in late 20th century that more attempts are being made from deductive scientists to reach social sciences methodology or be inclusive about social science methodology. And on the other hand, in social sciences, there's a paradox. There are two arms. One arm is the arm mesmerized by deductive methods, and there's a movement sort of something like we can do it better. So we can do it better. They are throwing the baby with the bathwater, and they are quickly losing the strength of their inductive logic while retaining the stubbornness of reflexivity. So they are suspicious about deductive methods. At the same time, they are gung-ho about the statistical comparisons and tests of significance. They are using SPSS for statistical comparisons while retaining the stubbornness or suspicious level of reflexivity towards positivism. There can be merits in their arguments, but the shaking hand, the process of shaking hands is seeing much more resistance from social science methods rather than biomedical research is gradually is very uneasy and uncomfortable about its own deficiencies, and they are quickly realizing that the culture of evidence-based medicine is killing the art of medicine. So inductive research methods, qualitative methods. On the other hand, the social scientists are losing their character of inductive researcher, and they are joining the bandwagon, and they are looking more like deductive researchers. So probably what should have been done, we would talk about that a bit later in my later phase of the slides. Emergence versus hypothesis testing is another concept here. Uh, Qualitative research methods very firmly believe in emergence, and quantitative research methods, their business is testing hypotheses. Qualitative researchers end up generating hypotheses to be tested by deductive research methods. Qualitative research is explicitly emergent. It does not test a hypothesis. When we go to SPSS, when we go to variables, when we go to measuring variables, then we are in the business of deductive research methods. And that's a slippery track, slippery or sticky wicket for inductive approach. However, we can quickly generate a middle path, but for the new learners, we must familiarize ourselves of what is a hypothesis. Basically, there are two components in any hypothesis. The simplest hypothesis is a relationship between this and that. You decide about this and you decide about that. You decide, maybe deciding about this means x1, x2, x3, xn, and that may be xy, may be binomial dichotomous, may be polynomial. So if this, then that is a basic simple hypothesis. This hypothesis can never be tested through inductive methods. For that, you need to break the reality into variables and measure them through mathematical methods. The qualitative research, the distinction is between emergence and forcing. When we break a reality into variables and we force a hypothesis over those variables, we forget that we are forcing the hypothesis over variables. We are not forcing hypothesis over reality, and we would apply the results over reality, not over variables. So if a patient is broken into variables and a hypothesis is tested on variables, probably the results are not applicable to patient, and we forget about that reality when we apply, when we be prescriptive about preventive or prevention. That's the basic pitfall in the deductive approach in biomedical research. The tension is between emergence and forcing, and insights against measurements. I've been talking about measurements, but where the insights? Insights would come through social science methods, through qualitative research methods, through inductive approach, through emergence, not through hypothesis testing, not through variables, not through ANOVA or chi-square or logistical regressions, linear or non-linear regressions or correlations. They are statistical methods. They will ultimately deal with the stochasticity. And qualitative research methods are very suspicious about stochastic models. On the other hand, quantitative research also revolves around research questions is common to them. One is the inductive approach towards research question. The other one is deductive approach towards the same research question. But one approaches the research question by breaking the reality into variables. The other one approaches the research question by seeing the reality as a whole. The first approach, the previous slide that I was showing was seeing the reality as a whole. But this slide is trying to break the reality into different variables and testing a hypothesis. Again, repeat, what is a hypothesis? If this, a bunch of independent variables, then that singular or a bunch of dependent variables. So there are two baskets and the relationship between two is maybe a postulate or a hypothesis. The simplest form of hypothesis is if this, then that. And that can be tested through only deductive methods. Some of the inductive researchers have also argued, especially Michel Patton, that we can test hypotheses through inductive methods as well. But the method and the entire grammar of hypothesis testing in inductive approach is radically different. Again, I would try to underscore the tension between two approaches. The tension is between emergence versus forcing, tension between insights versus measurements. And you can replace versus with and. So emergence and forcing, insights and measurements, all four complete the actual path to address a research question. Now, I would ask the learners to approach this table, forget about other rows, concentrate on the top and the bottom row. That basic differentials between qualitative and quantitative research methods. One is reason, as I have already explained. Qualitative means inductive and quantitative means deductive. Then strength, validity and reliability. They are look-alikes but have different concepts. Validity means measuring something that we intend to measure. And reliability is repeatability. Every time we measure blood sugar, it would be within that standard deviation, within that standard error, within that confidence interval. So if that falls within that confidence interval every time, that then it means I'm reliable. But it doesn't automatically or necessarily mean that I'm valid as well. So validity is the strength of qualitative research methods or inductive approach. On the other hand, reliability is a strength of deductive methods or exact sciences or deductive, quantitative research method, deductive approach, exact sciences. Reliability is doesn't necessarily mean that validity would be an essential weakness in deductive methods or reliability would be an essential weakness in inductive methods. Now, I would talk about the validity related issues with some details. There are four types of validities or major three types of validity. The other is a methodological concern about respondent validation. First is construct validity. What you submit at the protocol level is the methodological strength of a particular research proposal, how you are going to approach a research question or a hypothesis. That ultimately ascertains your construct validity. But how do you execute that protocol would ascertain the internal validity. That means, does it explain here where, suppose I'm doing a study in Delhi, does it explain the phenomena in Delhi? That is internal validity of the protocol, how the way I executed the study. Then external validity. Does it explain elsewhere as well? Is it applicable to India? Is it applicable to most of the sapiens in the world? Most of the patients in the world? Most of the diabetics in the world or hypertension in the world? If my study is about diabetics or hypertensive, then that is a question about external validity. A study that has a very good construct validity may be weak in internal validity because of the poor execution or a sloppy ways or sloppy application of the protocol while conduction of the research. External validity can be affected by two things. One is sample. Sample means sample size. That means how did we eliminate in selection bias. So sample size and sampling methods. But that aside, another thing that seriously affects the external validity is our inclusion or exclusion criteria. Some researchers, young, especially young researchers, and some very senior faculty members fall into that trap of making a very crowded statement about exclusion and inclusion criteria. We will exclude that patient, we will exclude that patient, exclude that patient, exclude. That means they are censoring their target population on which the result of this study are applicable or would be applicable. So what they are, the more you crowd your inclusion or exclusion criteria, the more you compromise your external validity. So we need to be a bit careful about that, that your target population on which the result of your study are going to be applied or going to be valid would be defined by your exclusion and inclusion criteria. Then finally, no one cares about respondent validation. There are very few studies after the emergence of a model. Do we actually go to the subjects of research or the participants of the research that we studied this thing with you as participant, and these are the phenomena that emerge, and we have reached this conclusion, we have made this construct or model. Are we okay? Are you okay with this model? Is there any error in this model? Do you think there is still we need to explore certain variables a bit more or further? So then we go to the actual participant of the research from where the data was collected. And that is the most critical part of respondent validation for zeroing or refining the model. Most of the researchers don't do that in both the domains, deductive or as well as inductive. But that's also a very critical validity issue. So there are four validity issues. All four of them are critical. Construct validity is defined by the rigor with which we formulated our protocol. Internal validity would be defined or would be decided by the rigor of execution of that protocol. External validity would be decided by inclusion and exclusion criteria and how good we were while eliminating the selection bias through sample size and sample methods. And finally, the respondent validation. That would be the final touchstone about the accuracy or applicability of our model. Now, sampling in qualitative research does not work in a deductive framework, so it's not a probability sample. Most of the time, it's purposive, or there are many other methods in qualitative research for non-probability sampling. We also call it a theoretical sample because it keeps emerging with the data collection, and we can change the sampling method or sample size midway depending on saturation or emergence of newer core themes. Such samples help generate insights but cannot test a hypothesis because in deductive research, the protocol is frozen once we start collecting the data. We cannot tweak with the sampling method or sample size after the protocol is approved by the technical advisory group and the institutional ethics committee. We cannot tweak with the protocol anymore. But in qualitative research, we provide a lot of liberty to the researcher depending on how the sensitive core themes are emerging and the saturation through the process of collection of data. We can change the size of the sample, we can change the methods of the sample. But either which way, while dealing in the inductive research, our sample would always be non-probability, and because of that, we should not make quantitative conclusions or recommendations at the end of a qualitative research. In quantitative research, we follow the probability samples. And we employ randomization because probability it is stochastic, so we employ bias. Relationship with bias is also very important to discriminate between two distinct approaches, inductive as well as deductive. Bias is not a taboo in qualitative research, and that may be surprising to you, many of you, because we have been trained through exact biomedical sciences and mathematics till 10+2 or through our graduation. All our life we have been trained in mathematical deduction. So bias becomes a taboo for us. In qualitative research, the researcher sometimes deliberately introduces a bias, say non-neutralizer client. If we wish to generate insights into a program, then we have to approach a non-neutralizer client. And there we induce a bias in certain, because if we reach a saturation in a particular core theme, we'll induce a bias midway through the protocol, midway through the conduct of the study, even after the protocol was frozen. In real science, protocol is never frozen in qualitative research. Freezing the protocol is the habit of deductive researchers. Inductive researcher would be very, very liberal and inclusive about most of the observations. Biases are generally treated as taboo or a differential. Differential error is a serious no in deductive domain. It's a non-differential error, then it's a random error. If it's a differential error, then it is going to tweak with your results, and a deductive research, honest deductive researcher, bias or a differential error would be a serious no. So this is a graphic representation how theoretical sampling starts, then data. This is the picture of a specimen qualitative study, not quantitative study. In a specimen qualitative study, most of these phases overlap. And they start with theoretical sampling, data collection, and you will notice that there's another bar here, sorting and analysis. And you will also notice that the analysis starts with day one. The day data collection starts, the analysis also starts. And sampling keeps changing all through the process of data collection. That you can also notice in this graphic. That sampling is a dynamic process. It is, the bar is moving with data collection, and analysis starting with the collection of data, or first FGD or first interview, you start analyzing the data. In deductive research, on the other hand, unless the last case is registered and the last bit of data on the last variable is recorded, you cannot start analysis. So this is the major difference between inductive versus deductive approach. Then there are some other conceptual disagreements. Qualitative research is very suspicious about variables. They say if you reduce reality into variables, it would be nearly impossible to recover the missing person from that bunch of variables. So they say that human experiences cannot be reduced into a set of variables. They are against that. On the other hand, Quantitative researchers consider inductive insights to be merely a bias in causal models. So when they construct causality models, they need variables and they need measurements of those variables. Qualitative researcher or inductive approach researcher would see this as mathematization of medicine or medicalization of health. And they would constantly argue against it. And they have very strong merit behind their arguments. Now, one of the cardinal concepts behind qualitative research is reflexivity. One of the cardinal concepts behind most of the social science methods or humanities methods deployed by experts in humanities is reflexivity. And reflexivity has epistemological roots, and statistically also it can be explained that it's something about circular relationship between x and y, independent variables leading to dependent variables. And if suppose y, one of the y is part of the basket of x's, then how do you deal with the situation? And the qualitative researcher says that that is not an exception, that is the rule. They say that the researcher is part of the independent variables. They say that knowledge cannot be separated from the knower. So knower is always part of the knowledge generation process. The knower is always a participant, and the participant of the research or subject, human subjects of the research are also participant, equal participants. And none of them is more equal than others. So when they are equal participant, the researcher also becomes a part of the basket of x's, x1, x2, x3, xn. Researcher is also sitting somewhere within that basket. Researcher is not an observer. So with that approach, every observation is a participant observation. But we know it fully well that participant observation is nearly impossible because of the etic and emic type of noise. And we will discuss that noise a bit later with Marvin Harris type of conceptual inputs in qualitative research. We'll discuss etic and emic type of issues a bit later. So there is a conflict between XY circular relationship and etic and emic. But here we should familiarize ourselves with the very cardinal and critical concept in qualitative research or inductive approach, and that's reflexivity. Reflexivity, the one sentence that explains reflexivity is knowledge cannot be separated from the knower, and the researcher is always sitting in the process of research and is a part of the variables or the independent variables. At least we must declare our conflict of interest. When we write a manuscript, we say conflict of interest, none. But in inductive research, there's always a conflict of research, and that's said in the somewhere later, we will be forced to realize that we always have a conflict of interest because of what? Because knowledge can never be separated from the knower. And that is because of this import of reflexivity, the researcher can never be separated from the bunch of variables. And since he or she is entangled in the bunch of variables, there's always a conflict of interest. We are dishonest when we say conflict of interest, none. Because financial conflict of interest is not the only conflict of interest. A researcher has a conflict of interest in the sense that he is part of that intellectual domain of inquiry. So he or she has an intellectual conflict of interest always. Now, etic versus emic. Kenneth Pike was a linguist. He was he was linguist, and he dealt with the nuances of languages and phonetic and phonemic domains of development of languages, lingual communications. Then Marvin Harris imported that idea into health sciences, public health, and he offered a simplistic expression, something like in any language, say they are say standard English language, and they are phonemics of English language, nuances of English language, phonemic or say accents, or we may India is full of phonemics. We are so rich in phonemics that even say we take Tamil as one language, then Tamil is spoken in Chennai is radically different than Tamil is spoken in Nellai area or Tirunelveli area or Kanyakumari area. So Nellai Tamil is radically different than Madurai Tamil. So what's the difference? Now standard Tamil may be same, but the phonemic Tamil or phonemic language is radically different. And those things were imported in health science research by Marvin Harris, and he provided a very simplistic explanation that what is etic. Phonetic means etic and phonemic means emic. So emic means native view and etic means investigator's view. When we go with a protocol, with a tool, with an instrument, with a questionnaire, that questionnaire represents the etic. But what is told in response to those questions is not etic or not purely etic. It may be emic or not purely emic. It may be a mixture of etic and emic. So emic means what the respondent tells us, and etic means what we hold a priori, what we hold. So hypothesis is essentially etic, and what is the result of hypothesis testing may be essentially emic in inductive domain. But and here the social science researcher would always be suspicious about deductive methods, that they say that we kill the emic in the process of hypothesis testing when we break the reality into variables and measure them mathematically, reduce them into kilograms and centimeters. Now I would skip this because this is just to familiarize with you that even the investigator may be harboring some emic. We take, suppose I am hypertensive, I take telmisartan 40 mg, but I also consume some Ramdev type of medicine. I go for non-pharmacological interventions as prescribed by GNC, but I also go for non-pharmacological intervention prescribed by my indigenous medicine. So I'm a prescriber to myself. There I'm etic. I'm practicing that prescription. I'm emic. But while prescribing those medicines and some non-pharmacological interventions, I'm etic, as well as some emic component is also induced in that prescription. And in my practice in following adherence to that prescription, somewhere etic is emerging as well as emic. Similarly, in the native, when the native responds to a questionnaire, he responds with some emic, and he is also, since we recognize now fully well that he is or she, the respondent, is also a participant in the research, then we have to recognize that he must be having his or her etic as well. So the respondent is not purely native. Respondent is participant in research. So he has or she has his or her emic as well as etic. So there are several types of tensions and conflicts: emic versus emic, etic versus emic, and etic versus etic. Now the bottom line: at the least, researchers who accept the status quo must acknowledge a conflict of interest. That is etic versus etic. And when we started about the intellectual conflict of interest, or knowledge can never be separated from the knower, there we need to be, if we are honest enough, we must not write none against conflict of interest. But since in the market of knowledge, conflict of interest means funding conflict of interest or career related conflict of interest, there we write none. But we all know fully well that we always suffer with intellectual conflicts of interest. Now, a word about grounded theory. Um, Dr. Saraswati, please remind me if I'm exceeding my time. Dr. Kiran, am I audible?
Yes, sir. Actually, the moderators will be taking care of time, sir. Dr. Sachdeva and Dr. Mitra, Mitra.
Oh, okay. How much time do I have?
I think it is just 10:54. You still have half an hour, sir, to go. No problem.
Okay, okay, fine, fine. So grounded theory is essentially many researchers think that they're indifferentiable from inductive approach or qualitative research methods. So they are one and the same: grounded theory, qualitative research methods, inductive approaches. And in 1967, Glasser and Strauss proposed grounded theory as against the grand theory. Grand theory is generally the exact theories of scientific examination and exact sciences. In social sciences, they propose grounded theory. And the grounded theory, there are two major thinkers behind the grounded theory. One is Glasser, the other one is Strauss. But later, because of the vicinity to the ruling structure of knowledge generation or business of knowledge, Strauss enjoyed a lot of attention, and he proposed a revised grounded theory in 1990 with a colleague Corbin. So generally the cardinal references about grounded theory in library are available with the name of Strauss and Corbin. Initially, it was generated by Glasser and Strauss. But to me, the Glasser was the original thinker and the proposer of grounded theory. He studied cancer patients dying in hospital and wrote a paper, Awareness of Dying, um, with constant comparative methods. Uh, Inductive approach is also iterative. Deductive approach is also iterative. SPSS, what SPSS does in background is mathematical iteration. What we do with the qualitative data through our rigor and toil is also a qualitative iteration. So constant comparative method is also iterative method. Ultimately, the discovery of grounded theory was published in 1967 by Glasser and Strauss. Later, Strauss and Corbin took over it, and there were ideological conflicts between them. Um, Grounded theory generally developed inductively, and it takes the case rather than again since it follows the inductive approach, it takes the case rather than a bunch of variables and takes different cases to be whole wholes. That means every individual is seen like the way during the days of art of medicine we used to approach a human subject as a patient. But these days, we reduce the human subject into MRIs, into biochemical investigations, we reduce them into variables, and we reduce them into organ systems. So, the grounded theory argues against this type of approach, and they take cases to be wholes in which the variables interact. We don't try to recover a missing person from the bunch of variables, and it also assumes that variables interact in complex ways and is, as I was talking, they are suspicious of simple additive models or ANOVA or linear regressions. Now, here's a comparison between Glasser and Corbin. And it's baffling that sometimes Glasser is much more liberal than Strauss, and sometimes Strauss is much more mathematical than Glasser. but these are the first top row and the bottom row are very important. And the cardinal, or say the critical statement made by Glasser is all is data. What you observe, what you scribble, what you memo, what you write on notepad, what you don't write but make a notation while writing a diary in the evening as field notes, everything is data. And that is the Glasserian, true Glasserian inductive or qualitative approach. Strauss says that data must go through the process of validation criteria. And he has made a validation criteria that looks more like a deductive research method. And yes, validation is the strength of induction, but the way Strauss and Corbin approach and evolve grounded theory, unfortunately, they reduce it to more of a mathematical or quantitative methods that can be handled statistically. And Glasser challenged him, saying that if you are so mesmerized with mathematics, then why don't you apply tests of significance on this data? Because you're tabulating your qualitative research data. Then on the other hand, paradoxically, Glasser, the bottom row, was inclusive about quantitative for triangulation, and Strauss was more qualitative in methods and stayed away with the quantitative data for triangulation. And when triangulation is needed, and why triangulation is needed for qualitative approach researchers, um, was underscored by Michel Patton in his treatise on evaluation sciences. And in that, he says that how solid is the evidence should not be tested through statistics. It should be tested through Glasserian approach, where all is data approach or all is data dictum is taken in toto. Then some history of uni-researchers. Um, Till 19th century, most of the manuscripts published in most of the scientific journals followed quantitative research only, and mathematics or statistics was considered the only language of science. But in early 20th century, research methodology saw a second emergence of a second phase, and qualitative methods started emerging. Polarization began, and then the then there was a serious conflict. People in positivism said that nothing is real unless you reduce the reality into a bunch of variables and measure every variable. On the other hand, inductive researcher, the second wave researcher, started arguing that reality is also a construct. And I'll invoke again, knowledge is not separable from the knower. So reality is a construct, and thus every reality is subjective. Nothing is objective. Incompatibility thesis, quantitative and qualitative paradigms could not coexist also started emerging, and that generated a lot of bitterness and conflict. Ultimately, we found a middle path, and they say that which approach is better. So we must ask ourselves, are we throwing the baby with the bath water? We need not get distracted by this uni-researcher argument, and instead of qualitative versus quantitative, our approach should be quantitative and qualitative, or qualitative and quantitative. Both the analyses put together will capture most and provide holistic evidence. Now, this is reality. Most of the time, this is the reality. Ill-demarcated, ill-defined, amorphous, amoeboid. And these are our research methods. Well defined, well drafted, highly stubborn, cussed. Now what we do, we force these methods over reality. And we must not underestimate the power of methods. The more we force the methods on reality, the more we suffer the risk of seeing the reality through the lens of our methods. And the results are written much before the data is collected. There's a allegation over deductive research methods. And again, I'll repeat, please don't underestimate the power of the methods. If we force our methods, we can change the reality. And that has been done in, this is just an example of horticulture market, that to reduce space for storage or to make storage more efficient, they started producing cubicle melons through methods. So if we force our methods too much on the reality would look the way we wish to hold it. Now, the second approach, the inductive approach is, here is the same reality, ill-defined, amorphous, amoeboid, and we develop an interface that has some ill-defined amorphous amoeboid edges and some well-defined interface to fit into our deductive methods. So middle fragment is inductive approach. On the right extreme is the reality, and on the left extreme is our statistical deductive methods of statistical testing. And then we can create an interface to actually let the deductive methods talk with the reality while having a sandwich of qualitative research methods. And as we decide, discussing in the second slide, that induction ends where deduction begins. What is induction? Induction is observe, define patterns, let the hypothesis emerge, and theorize. And then deduction, theorize, hypothesize, observe again, test the hypotheses, those hypotheses, and confirm. So the induction ends where deduction begins. Now, qualitative and quantitative, since we have left behind that discourse of qualitative versus quantitative uni-researcher mode, now every researcher has two hands, one qualitative arm, another one is quantitative arm. As and when it is found suitable, they need to be utilized in series, in parallel, or interwoven. And in our 2 decades old history at um, our partner organization, International Clinical International Clinical Epidemiology Network, we have a history of mega studies, injection practices in India, where we first went through qualitative approach, let the insights emerge, and informed by those insights, we developed our tools for deductive research. We evolved a protocol for deductive research, and finally measured the actual burden of injections on India. That was a very mammoth multicentric study nationwide, and that was a good example of inductive followed by deductive, qualitative followed by quantitative in series. Similarly, we evaluated integrated management on neonatal and childhood illnesses in study IMNCI blocks and non-IMNCI blocks, and we went through action research mode where qualitative and quantitative, both the arms were woven together, and urban rural control case. That was a very good example of deductive as well as inductive approaches being used in parallel in public health projects. Then now what a clinician does during daily ward rounds, or when you go to buy something from market, what you follow? You follow the Glasserian approach ultimately. And Glasserian was very inclusive about, he was suspicious about mathematics, but he was very inclusive about statistical data for triangulation. And here what we follow is Glasserian approach is very near to abductive approach, and that is generally done in most of our decision making processes, in our domestic decision making, in our professional decision making, or when a clinician takes a round and decides about a therapeutic modality to be prescribed to a patient, what he or she follows is an abductive approach. It starts with an incomplete set of observations and proceeds to the likeliest possible explanation. And based on making and testing hypotheses using the best information available, he makes an educated guess. Again, I'm committing a sin, or being a bit heretic here, because I'm moving beyond the convent of science. Educated guess, and can there be a room for educated guess in science? Yes, there is always a room for educated guess in science, and that we do day in and day out while doing the clinical practice, or deciding about the best public health approaches for a particular high risk group. So these approaches are called as abductive approaches, often used by doctors who make a diagnosis based on available evidence. And they are trying to break the cages created by evidence-based medicine. Evidence-based medicine is a fashion today, is a religion today, and now to evolve a science of medicine liberated from the religion of evidence-based medicine, the doctors are using abductive approaches. Similarly, in social sciences, you may evolve your own abductive approaches while weaving both the ideas inductive as well as deductive approaches in social sciences and humanities. Determining, now this is these are two last slides. Determining substantive significance. I've been arguing that significance or test of significance is a taboo in qualitative research or inductive approach, because we are using theoretical sample, we are using non-probability sample, so our data is not qualified for determining substantive significance. And instead of statistical significance, Michel Patton proposes something very, very unique. He says that qualitative findings are judged by their substantive significance instead of statistical significance. Readers will make their own value judgments. Readers of the produce of science, readers of the paper, publication, would make their own value judgment about significance. We don't freeze significance at 0.05 level. So it's not like statistical or mathematical or stochastic significance. It's a substantive, or say intellectual or abductive type of significance. And it is decided on two markers, consistency and synergy, and to what extent, in what ways contributed to. And consistency and synergy on two scores: internal consistency, that means triangulation across the methods. So triangulation across the methods means the same core themes are emerging through interviews as they are emerging through focus group discussions or ethnography or non-formal interactions. Then triangulation across stakeholders. Mother is narrating the same story, mother-in-law is narrating the same story, the child is narrating, contributing the same story, father is contributing the same story, Anganwadi worker is contributing the same story, doctor is saying something similar to that effect. So that means there is a triangulation across stakeholders. Then triangulation across methods, triangulation against stakeholders, there's an internal consistency. Then external consistency, is it in sync with the other papers, other evidence, qualitative evidence, other quantitative evidence available in the domain of knowledge? Then the second score is to what extent and in what ways contributory to understanding the phenomenon studied, and theory, policy, intervention or program. So do the results proposed in this paper help the reader in understanding the phenomenon and help the program managers to evolve further theories or policymakers to better inform the policy and the program managers to better inform the programs. Now, there is a very funny statement made by a mathematician and a statistician, quoting another mathematician, Fred Musler, the applied statistician. He was fond of saying that he did not care much for statistically significant differences. He was more interested in interocular differences. He uses a word non-medically, interocular differences, the differences that hit us between the eyes. That means if we are interested in real significance, we ignore little differences. We ignore them because A, although they are very likely real, B, they are very unlikely to hold up in replications. So Scriven, a mathematician himself, is quoting another statistician saying that don't get worried or don't be a hostage of your statistical methods. Don't be hostage of your softwares. Don't be hostage of your test of significance. You go back to Glasserian approach. All is data and the knowledge is never separable from the knower. If something is hitting you between the eye, it must be true. Go back to the data. I thank you for your attention.